Now we've got a presentation, and the guys for the next presentation have promised me they're going to tell us about tech that makes the invisible visible. So they are here to explain. So please welcome Dr. Mark Roberts and Graham Upton from Capgemini. Nice to see you both. Hey, it's all yours.
Okay, good morning, everybody. Very happy to be here. As we just said, myself and Graham are here from Capgemini. If you don't know Capgemini, very briefly, Capgemini is one of the world's largest IT system integration, engineering and R&D services company. So, and we're here to talk today about something slightly different. And maybe I'll just start with a question just to get you warmed up. A question, have you ever seen the wind? Can you just raise your hand if you've ever seen the wind? I see a few tentative things, and I see a few confused looks trying to figure out if that's a trick question. And to be honest, it is a trick question. We don't see the wind ever. The wind is invisible. We sometimes see the effect of the wind when it blows a cloud or a tree or a flag or a windsock or something like that, but we don't actually ever see the wind itself. It's a bit like light in that respect. We don't see rays of light everywhere. We only see light when it bounces off something else. So the wind is invisible, and that presents us with a bit of a challenge because in a lot of cases we really need to know what the wind is doing. We need to see the wind, we need to measure the wind. And of course we can measure the wind. We can put a sensor, an anemometer over there and another one over there, and we can get a very precise measurement of the wind at those points. But what about in between? What's happening in between that space? What's happening all over there and a mile that way? We don't know because we can't put sensors everywhere. And in fact, the only way we really can see the wind is by just releasing some smoke into the environment. And then we can actually see the wind swirling around, and that's great. It's great in one respect because we can see the wind, but it's terrible in another respect because we can't see anything else. You wouldn't want to release smoke over an airport, for example. Even though it would give you a really good view of the wind, you'd have a terrible view of planes and they'd start crashing into each other, right? So generally, this is a problem that we've had for the entirety of humanity. We've never really been able to see the wind. It's a completely invisible force, but it's incredibly important to lots of things. Clearly, if you're in the business of running an airport, being able to see the wind is like the holy grail. Imagine how different it would be running an airport if you fully could see what the wind's doing at every point over the airport space. What I'm going to talk to you about today is an example where we've actually solved that problem, where we were set the challenge to figure out how we could see the wind over a large area in real time in high resolution. And in this case, the application was sailing. And I don't know who's familiar with sailing or this sort of elite sailing. We were engaged last year with the America's Cup. The America's Cup is the world's foremost sailing event. It's the longest running trophy in international sports. It's been running for like 175 years. And it's normally known as the Formula One of the seas, in that there's huge amounts of money, of technology, of innovation, of glamour that goes into this sport, developing these amazing looking boats, which actually don't look like boats. They probably share more with a modern aircraft than they do with a traditional sailing yacht. And obviously in a sailing race, the wind is the most important factor in determining who wins the race. But it's also completely invisible to everyone. The crew on the boat, they can maybe see some of the wind, just by the way it interacts with the waves, but the people, the spectators can't see it, none of the teams can see it. Crucially, the TV audience has no idea what's going on. They don't know why this boat turned left or right, and whether that was a good thing or a bad thing. So not being able to see the wind has really hampered people's engagement with sailing. So that was the challenge that we were set by the America's Cup organizers. Could you please develop some technology that allows us to see the wind over this enormous race course, which is about 5 by 3 kilometers, and we would like to have a measurement of the wind every 10 meters over that race course every second. And that's what we did with our WindSight IQ technology. I'll just play a 60-second video that explains some of that.
The wind is a decisive force to master and a challenge to reflect on screen. Combining tech, data, design, and engineering, Windside IQ brings the digital and physical worlds together. Using advanced sensor technology, the solution scans the race area to capture the velocity of air particles. Algorithms then transform the data into a wind map of the course, enabling real-time monitoring to create a captivating broadcast experience. A virtual wind field shows race conditions. Live footage is augmented to imagine crew tactics, and ghost boats show optimal routes and potential results. Providing fans with these insights for the very first time, Windside IQ reveals a new face of the America's Cup.
Okay. So that gives you a 60-second teaser of that solution. I mean, there's a huge amount more I could say about that. We don't have time today. But the crucial thing there is that we solved this problem of seeing the wind at large scale over a large area in great detail. So with the America's Cup, the challenge we have is that they already use some wind sensors. So typically on one of their race courses, they have between 6 and 10 wind sensors out there on the course. But that's really only measuring just a few tiny points over a massive 20 square kilometer course. It's nothing really. It doesn't really give you a picture of what's happening over that race course. So the solution we developed uses LiDAR, and I'm sure many of you in the airport world are familiar with LiDAR. A lot of airports use LiDARs right now to examine some aspects of the wind. But this is kind of different. What we've done here is that we've solved the general problem of how do we mesh together and fuse multiple LiDARs into a single coherent picture of the wind. So we have multiple LiDARs, in this case around the coast of Barcelona, scanning the same piece of air, the same particles of air from different angles at the same time. And that allows us to completely and correctly resolve the wind speed and direction at that point. And we did extensive validation exercises, which unfortunately involved sailing pleasantly around Barcelona Harbour in the sun for a few weeks. But we're able to then accurately validate and measure that our solution was actually giving the right answer. And the contrast couldn't be more different. The race went from having 6 or 10 wind sensors to effectively having 300,000 virtual wind sensors over the entire course. We can see every 10 meters what the wind is doing, what speed it is, what direction it is, and we're updating that every second. And that gives us these amazing ability to visualize and measure what the wind's doing over that very large area. And you can also actually see, you can start to see effects that were just not visible before. On this video, I don't know if I have a pointer here. No, it doesn't work. The dark blue patch on the left, if you're watching the video, you actually see it sort of propagating out from the shore. That's actually what we call a wind shadow from a hotel. There's a hotel on the corner there called the W Hotel, which is shaped like a sail, actually, and it generates this wind shadow. And no one had ever seen that sort of thing before. It's just not possible to see with just a few point measurements. But once you can see the whole thing at once, then you start to get a much better appreciation of the dynamics, the flows, the turbulence within that space. And the best thing about this, I need to give a quick shout out to the team. I'm very lucky to work with an amazing team of people in Capgemini. This whole project happened within about 7 months. We went from having a very basic academic hypothesis. Literally, a professor had said, I wonder if it's possible to fuse multiple LiDARs in this sort of way. And we did everything there from the early R&D, from the algorithm development, finding suitable LiDAR vendors, doing integration with those, with that LiDAR hardware, which is normally designed as a very passive capturing device, to turn it into a robust real-time streaming device that was feeding huge amounts of data every second back into our algorithm. Doing all the software integration, integrating with the America's Cup systems. I didn't realize this before I started, but the America's Cup is streamed to over, well, just under 1 billion people in a live audience. So this is a system that had to work, and it had to work reliably. And we went from nothing to having a fully robust and validated system within just 7 months there. It's a pretty amazing achievement, actually. So with that, I'm just going to, you're probably wondering at this point, is this guy in the wrong place? This is an aviation festival, and he's here talking about boats. So hopefully you've put two and two together and realised why this is relevant to the airports world. But if not, my colleague Graham will talk a bit more about that specifically.
Brilliant. Thank you, Mark. So yeah, I'm going to talk a little bit about how we might apply this amazing technology to airports. So, one of the things that we're always worried about, we've heard it this morning, we've heard it in the last 2 days of the festival, how do we increase airport capacity? So one of the ways we've tackled that on approach is by using LiDARs for things like pairwise separation, but this hasn't been done for departure. So departure is mandated by regulations, ICAO regulations based on different types of sizes of aircraft. An A320, for example, based on its wingspan, is what we call a Code C aeroplane. But if you're sitting behind an A380, that means you have to wait a defined time. So how many people in the room are frustrated that you sit on the runway, you're on the taxiway, you're at the end of the runway, and you've got to wait what seems forever before you can take off? And that's nothing to do with the air traffic controllers. There are mandated regulations that say you have to wait 1.5, 2 minutes, or even 3 minutes, depending on the type of aircraft. So what we're looking at here, and is, the aircraft, when they take off, create vortices. And these vortices are caused by the wingtips. They tend to sit at the ground level. You can see on the left-hand side there. The current departure assumes those vortices are there, irrespective of the weather conditions, the type of runway, and the parallels. If we could see the wind, as Mark said, and we know the vortices have dissipated, which they can based on weather conditions, we can allow the aircraft to take off more quickly. So we're clearly talking to all the regulators about this and air traffic control. So if the air traffic controller knows that the vortex has dissipated, we can allow the next aircraft to go quicker. And that could be a game changer, because financially that's worth millions and millions per year, because we've looked at typical days across certain airports with maximum capacity limits, and we could get maybe 25 to 40 aircraft a day extra. That's a huge amount of revenue for airports. So this is why we believe it's quite exciting. So you can see there on the right-hand side, the vortex has moved away and dissipated, and we can allow the next one to go. So I've shown there an A380 and an A320. So reducing the wait times on the ground is really, really important. The other benefit as well, safety. Things like wind shear. That's a big issue. If we could see wind and we are more able to do that, that's a huge benefit from a safety perspective. What about the environmental side of it as well? Less aircraft idling on the ground has got to be good for the environment. And we're very conscious in the aerospace industry that we want to reduce emissions. So, less ground idling has got to be good. And then finally, there's other things. So eVTOLs are coming along a lot. So we're working with some eVTOL companies. They are very sensitive to wind, especially in what we call the transition period, where they go from horizontal to vertical flight. eVTOLs are going to be flying into our major airports. They will be flying into heliports and things like that. Again, we can see by putting the LiDARs in the right position and validating the software. And the other thing as well, there's something, certain airports use something called RDD, which is reduced divergent departure, which means aircraft can split off, which means you can get aircraft out faster. However, communities complain, because if you see an aircraft now flying over your houses, the airports get complaints. So there's a benefit there from the passengers and community. So, this is multifaceted, the benefits that we're seeing. So in summary, we think we've got an innovative solution, by visualizing the wind. We think this is groundbreaking innovation, and there are many broad technical applications as well outside of what I've just showed. We think in terms of industrializing the process, enhancing safety in certain environments is really, really important. And the main thing is obviously operational and financial impacts, because that at the end of the day is what it's all about in the aerospace industry or the airline industry, is getting more aircraft in and out of airports, especially at peak times when we're trying to get aircraft in the morning or in the evening. So we are starting trials at a UK airport very soon to validate all of this. It's all very exciting. We'll clearly let you know more about that as these trials progresses. But we'd like to invite anybody to come and talk to myself and Mark after the presentation. We're Capgemini. We'd love to talk to you about how this may be applied in your airport with your airline support or any other application that you might have thought of. So thank you very much for listening this morning. Hope you've enjoyed the presentation.